Welcome to Trajectory Part 3. And if you take a look at the screen, you see we're going to do a simple problem of a ball rolling off a cliff. We have a ball moving to the right at 15 meters per second. It gets to the end of the cliff and it falls down to the ground. It follows a path called a parabola. I'm sure you're all familiar with that from your math classes. It lands some distance away from the base of the cliff, S sub x. The cliff we know is 44.0 meters tall, and that is the distance S sub y. Two pieces of information we need before we forge ahead here is x and y motions are independent. That means the motion in the x direction has nothing to do with the motion in the y direction. Whatever value you calculate for the x's, you don't need to worry about for the y's. And when you calculate values for the y's, you don't need to worry about the value of the x's. Number two, the velocity in the x direction is a constant. In other words, the ball is moving at 15 meters per second, and it's going to continue to move 15 meters per second in the x direction until it hits the ground and stops. So, first of all, let's find out how long it takes the ball to hit the ground. To do that, we're going to use S sub y, 1/2 a t squared plus v0t plus s0. Now, a couple things right away. This value is 0. Because we start at the top of the cliff, there's no displacement, and all the motion initially is in the x direction, so there's no velocity in the y direction, so this part of the equation turns out to be 0. We are told that the height of the cliff, or S sub y, is 44 meters. It's equal to 1/2, just a constant, and we're near the surface of the Earth, so A is actually equal to g, and it's a positive g because the object is accelerating or falling down. Solve this equation for t squared, 88 meters, divided by 9.8 meters per second square, gives us a t squared of 9.0 seconds squared, and the value of t is equal to 3.0 seconds. So it takes 3 seconds for the ball to fall from the top of the cliff to the ground. Next, we're going to find out how far away from the base of the cliff it lands. And to do that, we're going to change the color of the pen, so give me 1 second here. S sub x is equal to v sub x times t. Now, why this simple equation? Because the velocity is a constant, and this is the equation we use. Distance that falls away from the base of the cliff, 15 meters per second. Remember, we said that the velocity in the x direction is a constant, times the amount of time, 3.0 seconds, and the object lands, in this case the ball, 45.0 meters away from the cliff. Pretty straightforward. Lastly, we're going to find out what the final velocity is of the ball when it strikes the ground. We're going to use the definition of acceleration, which is nothing more than the final minus the initial velocity divided by the time. Now again, we're still near the surface of the Earth. The ball is accelerating downward, so A is equal to positive g, 9.8 meters per second square. Final velocity is what we're looking for. Initial velocity is 0 meters per second. All the motion was in the x direction, and the time we calculated to be 3 seconds. Final velocity is 9.8 meters per second square times 3.0 seconds, gives us a final velocity of 29.4 meters per second.